Welcome to today's webinar, GNSS Constellation Update. My name is Joe Winans and I will be your event manager. Before we get started, I want to let you know about today's webinar, that it's being recorded. You're currently in a listen-only mode. At this time, I'd like to acquaint you with the ways in which you can participate during today's presentation. In the lower left-hand corner of your console, there's a submit button for your questions. We encourage you to ask questions throughout the presentation. Just type in your questions in the text box at the bottom left, then click Submit to place your question in queue. And there are no limits on the number of questions you can submit. Questions that were sent to us during registration will be covered in this webinar, or perhaps covered in EricGakstatter's e-newsletter. Finally, if you experience any technical difficulties, you can also use that question box to submit those, and we will respond to you. GPS would like to thank our platinum sponsor, Hemisphere GPS, for making this webinar possible. Now, without further delay, I'd like to turn today's event over to our moderator, EricGakstatter.
Thanks, Joe. Hey, it's great to be here this morning from cloudy Portland, Oregon. Well, it's been a few months I've done a webinar, and great to be back talking about stuff that I've seen and heard and has happened over the past few months. Just by way of background, I'm editor of the GPS World Survey Scene newsletter and editor of Geospatial Solutions. If you've not noticed, we've gone through sort of a server transition on our website, so all the archives aren't quite there yet, but we're getting there, so just be patient with this. So here's the subject matter I'd like to cover today. I'm going to get you caught up on the status of the GPS constellation, GLONASS constellation, Galileo, China's BeiDou compass, and then some SBAS updates, as well as some news and trends. I've been traveling quite a bit lately and hit many of the conferences out there. I was over in Germany a couple weeks ago and down in Nashville at the Iowan GNSS conference last month. So lots of sort of interesting stuff to catch you up on, and hopefully you'll get a kick out of it. So first of all, I'll start out with GPS. You know, GPS has been kind of slow in their launches over the past few years. You've probably noticed that, but it's been about this once a year pace. Last month, they launched the third of 12 of the new 2F models being produced. And sort of the great part about the 2F is it has 3 civilian signals on it. The L1CA, which is the legacy one that we're all used to using. It's got L2C on there, and then the new L5 signal. And the interesting part is, even though there's all these new signals, civilian signals up there, we're really only using one out of those 3, and still the legacy L1CA. And the primary reason is just aren't enough satellites up there broadcasting L2C. I think there's 9 satellites, maybe 10 at this point, but I think it's 9 broadcasting L2C, and then only 2 of them broadcasting L5, because the one that was launched last month isn't healthy yet, if I'm not mistaken. So we really aren't seeing the benefit of all these planned civilian GNSS signals yet, or GPS signals yet. And the interesting part is that there's 4 to 5 2F satellites waiting in the warehouse, so to speak, that are completed and waiting for launch. But the issue, and I've talked about this before, is really the budget more than anything else. And we talk about GPS having 3 segments, but it's actually got 4, I think. One is the user segment, the other is the space segment, and the third is a control segment. The fourth one, I think, is really referred to as the budget segment, because it's a big driver behind how quickly GPS satellites are launched that have these new capabilities. And of course, the slower they are launched, the less able we are to take advantage of these. And so, and just remember it costs about $60 million to $70 million for the military to build a GPS satellite, and it costs between $150 to $200 million to launch it. And so, of course, in these economic times, when U.S. Congress is looking at crunching the budget and cutting back, all of a sudden, they'd look at the GPS folks and say, look, we have 31 healthy GPS satellites in orbit. Why spend 150 to 200 million per satellite to launch them? And so that's why you have sort of a backlog of satellites waiting to be launched. In this next slide, it's kind of a cool slide. Just it shows you a picture of the typical Delta or a Delta IV satellite with the GPS 2F payload in it. It shows, on the left there, it shows shows on the launch pad, and on the right shows you a blow-up drawing of the rocket itself. I think just an interesting slide. So just to summarize the current satellite constellation for GPS, there's 22 of the Block 2, the legacy Block 2 satellites, and part of this, I guess I could call it a problem, or part of the lack of urgency to launch the new satellites that are ready to be launched is that these legacy Block 2 satellites are just performing really well. I mean, if you think about it, they were designed with a 7.5-year lifespan, and some of those, I think one of them's been up there and is still operational after 22 years. And so, of course, they want to get as much use out of them. And so, part of the problem here is that the legacy ones are performing so well that there's a hesitancy, or there's not an urgency to launch the newer satellites being developed. Then, of course, there's 7 of the Block 2 RMs, and they have the new L2C civilian signal on them. And then there's 2 of the newer Block 2Fs. The first one launched back in 2010. The second one launched 2011, and the third one was launched last month. But of course, it's not listed here because it's not healthy yet. But it's also got the L5 signal on there, and really the benefit of L2C and L5, are results of lessons learned by the first civilian signal, the L1CA. So L2C's, it's got it's going to basically give us a civilian signal on L2, which we've never had before. That's sort of the key thing. So there's no need for the semi-codeless technique, which really hammers the signal strength on L2 on the receivers we see now. I'm not going to touch on that today, but I've talked about the semi-codeless technique and the impact of it. In the sunset, they're going to discontinue supporting the semi-codeless technique in 2020. If you haven't heard about that, you can look up at the archives and some of the articles I've written there. But so L2C gives us gives us the civilian community direct access to L2C, which really doesn't happen today. The engineers have to use a semi-codeless technique to get to L2 through L1CA, and it really has some penalties there. So L2C is actually it's really going to improve a lot, but there's just the problem. Improve performance of high precision receivers a lot, but the problem is there just aren't enough of them out there right now. And then L5 is a whole different ballgame, and I'll talk about that a little bit later on in the slides. But I mean, if you can imagine, it's got a 4 times stronger signal strength than L2C, and it's just a much improved signal. So then the magic sort of behind L5 is a couple of things that are really key, in my opinion. One is, of course, it's an open signal, and if you look back, the legacy dual frequency high precision GPS receivers, the only civilian signal was this L1CA. The only way we were really able to use L2 in the civilian markets is some pretty smart engineers back in the 80s figured out how to cross-correlate L1 and L2 and use L2, because L2 is a military signal. The PY code on L2 is a military signal that's encrypted. So as civilians, we were unable to use it, but some pretty smart engineers figured out how to use it, albeit with a penalty of signal strength. But the key behind this L5 signal is it's a completely open signal. It was developed specifically for the civilian user community, so there's no tricks to play there. It's a direct signal, so civilian receiver manufacturers can design it to receive a receiver that will receive L1CA and L5 for a high precision dual frequency receiver without playing any tricks. So you're going to see a fantastic increase in signal strength from L5. So number one is it's an open signal, and I underline that because I think it's really a key thing. Number two it's supported by other global GNSS and SBAS, and I have a chart here in a second that I'll show you. But it's really kind of interesting to watch this and how it's going to pan out in the future. But L5 is supported by Galileo, supported by Compass. So it's and it's also supported by SBAS systems like WAS and EGNOS and so on. And at this, as it stands now, GLONASS doesn't support L5. They have plans for it in the future, but in the space business, talking about the future is, years or 10 years or 15 years out. And of course, I mentioned before, so those are the first two things, is that the key things for me is it's an open signal and it's supported by other GNSS, global GNSS, and SBAS. Again, broadcast strength is 4 times more powerful than L2C. It's got longer code and error correcting techniques for more robust tracking and in difficult environments. So in addition to having a stronger signal strength, it's got more robust tracking due to just improved code structure from lessons that were learned on L1CA. Also, L5 is located it's a highly protected aeronautical band, because really L5, the major driver behind the development was the aviation market or the aviation industry. And so it's in a piece of spectrum where you're not going to run into issues similar to LightSquared, where somebody wants to co-locate in an adjacent or locate in an adjacent frequency to L5. It's sort of in a space that you're not going to have that kind of issue like we do with L1 right now. And so down towards the bottom there, my opinion is that the availability of L1, L5 dual frequency receivers will increase dramatically on a wide range of chipsets, and that will drive prices for high precision GPS receivers down, because there's a lot of intellectual property and patents geared around this whole L2 semi-codeless technique of being able to cross-correlate and use L2, even though it used to be a military encrypted signal, or is a military encrypted signal, but before L2C was developed. So, what I think might happen is eventually the dual frequency receiver of the future won't be an L1, L2 receiver. It just might end up being an L1, L5 receiver, again, because they're completely open signals. And just sort of look at this, and is that both Galileo and China's BeiDou Compass system support L5, and that would further add to the GPS constellation broadcasting L1 and L5. And I've got this kind of a tiny graphic in there, but it shows a combination GPS Galileo constellation. Galileo is targeted at 30 satellites. GPS is up around 30, even though it's optimized for 27 satellites. But anyway, the result is that you've got 20 plus satellites in view between GPS and Galileo, and boy, you add in China's system at 30 satellites, and then all of a sudden you've got 90 satellites and probably 20 to 30 satellites in view. And so it sort of raises the question, hey, where is GLONASS going to fit in? I mean, GLONASS has really served us well in the past decade, certainly. I've upgraded to GLONASS on some of my receivers, and it just makes a huge difference when you're out working under and around canopy. But what's the receiver of the future look like? Does it really include GLONASS? And that's a question. It's a valid question to ask, because it doesn't support L5. Where all the other global SBAS or all the other global GNSS do. And it also raises the question, okay, what about L2? Does L2, do all receivers migrate towards a GNSS L1, L5 receiver? Is there a reason to have L2? Yeah, you could probably say it's a useful add-on feature, but is it really required? I mean, you can still get a high precision accuracy with a dual frequency L1, L5 receiver. What more is L2 going to add in the future that we can't get? I mean, yeah, I'm sure there'll be, some of the high precision manufacturers will make a, L1, L2, L5 receiver and price those at a premium to quote unquote receive all signals in space. But that certainly won't be the entry level type of receiver. This next chart, if you've attended some of my webinars before or presentations, I display this one quite a lot because it sort of backs up what I'm saying here. If you look at on the right side, that column box is drawn around the L2 frequency, and you can see, down the left-hand column, it lists, all the current and planned GNSS, and virtually all of them support L1. So certainly that's the common denominator among all of them. And if you slide over to the left, you can see L2, which is probably 3/4 of the way to the left from the right, and you can see there's not a lot of support there. Yeah, certainly there's GPS support, certainly GLONASS, but if you slide all the way over to the left, and that's the L5 column, you see a lot more support for L5. And it's just, I just see this as it's a pretty clear trend to me on where receivers are going to head. This next slide just shows, the improvement of the code structure and performance of L5 over L1 for tracking, and you see the scatter plot is in red for L1 and in green for L5, and so you can see a pretty dramatic improvement in performance of L5. So the L5 takeaway, the takeaway messages are the new L5 signal will result in very low cost dual frequency receiver capable of centimeter horizontal and vertical precision. High precision GPS receiver will be available at a very low cost as compared to today. And then also Europe's Galileo system could accelerate a full L5 constellation, because if you look at the GPS launch schedule, as much as you can learn from what the DoD is telling us, we're only going to have probably 12 satellites in the 2014-2015 timeframe that are going to be broadcasting L5. But the Europeans are actually on a pretty fast pace right now, and I'll talk about Galileo in a minute. But they're launching at a pretty good clip, and so in that same 2014-2015 timeframe, which is only 2 to 3 years out, there could be as many as 30 satellites broadcasting L1, L5 between GPS and Galileo. And I've got, and so therefore, oops, I think I've got a slow connection here. There we go. Okay. I've got one more here. I'm trying to push this slide out here, and I think it's trying to catch up still. There we go. So the value of high precision data, both horizontal and vertical, will reduce substantially. So a company that's geared around providing location services, just go out and locating points, high precision points, both horizontal and vertical, the value of that data is going to reduce substantially, I think, because the equipment is going to be available to a broader audience because it's going to become so much cheaper than it is today. So you can imagine, I mean, and I'll give you an example. As I was down at the ION, the Institute of Navigation GNSS conference last month, and one of the keynotes at our GPS World Dinner event that we hold down there was a gentleman named Todd Humphreys out of University of Texas at Austin. And he made a prediction that by the year 2020, all mobile phones, not all mobile phones, but mobile phones will have RTK capability. So in other words, centimeter capability in your mobile phone. And I tend to agree that's the direction it's going to go. In fact, I think it may be even quicker than 2020, because I think what will happen is probably in the next 3-year time frame, you'll start to see when there's enough satellites up there broadcasting L1 and L5, I think you'll see a fair number of companies develop, little puck-size L1, L5 dual frequency GPS receivers that will have, communications built in, for example, GSM or CDMA, to your wireless networks like AT&T or Sprint or whoever your local providers are. And then also Bluetooth connectivity built in. So you'll be able to Bluetooth to that little puck, which got a battery inside of it too, and stick it on top of your ball cap or on your shoulder, in any other location, and Bluetooth with your iPhone or your Android phone or your Windows mobile phone or whatever, and be able to access centimeter level accuracy data from your phone, and just run the app, whatever it is, on your phone or on whatever mobile device you have. It could be an iPad or any other Android tablet or a Windows tablet or any kind of tablet computer. And you think about how far we've come in just the past 5 years or so. Is that how expensive were tablets 5 years ago, because the iPad didn't exist, and tablets were $2,000 to $5,000 range a piece, and dual frequency receivers certainly were that $5,000 to $10,000 to $15,000 a piece. And looking out, look how it's going to change 5 years out from now, or even 3 years out from now, where you can get a tablet computer for well under $1,000, and a high precision dual frequency puck for, I think, well under $1,000 too. And so when the price comes down that dramatically, it's going to open up all this technology to a much, much, much wider audience who will be able to collect this type of super accurate data. So the skill and the time required to collect high accuracy data will fall substantially. Manpower requirements will shrink as productivity increases. Projects that will take a lot less time to complete than they do today. And so I think companies that rely on high precision locating for the revenue is going to really heading for a sort of an economic storm, I think. So I've come to my first poll here, and I'd like you to, for those of you who haven't completed a poll yet, you can select one of these answers. So the question here I'd like to, and this is something that we all participate in, and as an audience, and then I'll push the results out here in a minute and show you, and then I'll publish them in my future newsletters too, just to give you an idea, because it's always great to sort of understand, I think, what your colleagues are thinking about too. So the poll question is, how much influence does the change in GPS signals have over your GPS equipment purchasing decisions? Answers are, hey, I pay close attention to this subject because it's important to me. Number 2, I rely on my local dealer to keep me informed. Number 3, my current equipment is working fine, so I do not pay much attention to this issue. And 4, I just don't know yet. So go ahead and click on one of those and hit submit your answer, and I'll broadcast some live results here in a second. And then I'll move on to the next subject, which is a Galileo update. Joe, can you go ahead and push out the poll results for me, if you don't mind? Oh, there you go. Actually, I think I've got it here. Nope, no, I don't. Joe, if you don't mind, can you push them out? And if they're not displayed yet, 67% of you said you pay close attention to the subject. 8% say you rely on your local dealer to keep you informed. There you go. 5% say your current equipment works fine, so you don't pay much attention to it. And then, of course, 18% say you don't know yet. I mean, I'm sort of a mixed bag on what. Of course, I pay close attention because I'm deeply involved in this stuff. But I've got some equipment that is working fine. That's GPS legacy equipment that's over a decade old, and some newer equipment too. But if these aren't the final numbers, I'll end up posting them out there on my newsletters, and you'll see a summary. So the next subject is Europe's Galileo system, and to me, it's pretty exciting what Europe is doing right now. So just a summary: they launched their first 2 operational Galileo satellites last year, after a decade plus of debate and discussion and figuring out financing and all that stuff. And I won't get into the background of that too much, but it was the difference between Galileo and GPS and GLONASS is Galileo is a civilian system, whereas GPS is funded by military and GLONASS is funded by military. Galileo is funded by the civilian space for civilian applications. So that was the challenge they had, is how do you finance that? Because you couldn't pull it out of the military budget. You've got to finance it with civilian public dollars or private dollars. They tried to with a private-public partnership, but it didn't work out. So it's initially being funded by public dollars. 2 more Galileo satellites were launched earlier this month on October 12th. So there's 4 operational satellites in orbit. I guess they're in test mode right now, so they call them IOV, which is initial orbit validation. And that testing will, so these first 4 are designated for testing, and the testing is scheduled to occur between now and then next summer. And then next summer is when the production launches begin. And I'm told they're going to begin in the summertime, and then every 3 months after that, they're going to have a launch. And the difference, one of the differences is that Galileo satellites are launched in pairs. They launch 2 at a time, 2 on a rocket. But they also have a contract in place where they can launch 4 on an Ariane 5 rocket that will begin in about the 2014, maybe the end of 2014 timeframe. And so they can put a lot of satellites up in a hurry, whereas GPS is limited to 1 per at this point. So their projection, Galileo's projection, is that they have a constellation of 18 satellites in orbit in the 2014 to 2015 timeframe. Again, it's highly compatible with GPS L1, L5, and there's no L2 support, which is interesting to me. And again, I come back to this signal plan here, and you see on there that there's not a lot of support for L2, none for Galileo, of course. So it's an interesting subject to look at, is where L2 is going to end up. So if by 2015 Galileo has 18 operational satellites broadcasting L1, L5, okay, and GPS has 12 operational satellites broadcasting L1, L5, that's a 30 satellite constellation, which is very usable for us. And so I did some simulations based on predicted orbital slots for all 30 of those GPS and Galileo satellites. And I've published these before if you've seen them. But this first slide shows the number of available satellites, and the vertical axis is the number of satellites in view. And I think I used Portland as my mission planning point. And then the horizontal axis is time, 6 in the morning to I think it was 8 at night. And you can see that there's only 12 satellites in orbit broadcasting L1, L5, and these are the 12 GPS satellites, then you don't get that many in view. You get a maximum of about 6 of them at one point. So it's not really a usable constellation at all. Now, if we look at the number of Galileo satellites, and this is 18. Remember, this is the 2014-2015 time frame when you're going to have 18 of them up there projected. It looks a little better. Again, same vertical and horizontal axis. You'd be able to see up to 7 Galileo satellites in view at any one time. But again, it's not really a usable constellation by itself. Okay. What becomes interesting is this next slide, is when you add those two systems together, GPS and GLONASS, the past 2 slides, you add them together, then it starts to become a really usable constellation. And this is based on a 15-degree elevation mask. So the low point is going to be 5 satellites there at the beginning, but it gets up to as many as 12 satellites during the day. And then the last satellite here, the last simulation, the last slide, shows you. I think the internet connection is a little bit slow here, but it'll be pushed out in a second. But this last satellite is going to show the combination of the new L1, L5 GPS, the new L1, L5 Galileo, plus the old legacy GPS satellites. They don't support L5, but they still can add the solution. And you see in this scenario, you're going to see anywhere in 10 up to 15 satellites in view. And of course, you can extrapolate this even further and add in GLONASS. Again, don't support L5, but certainly they can add value to the constellation too. So tons and tons of satellites in view. So here's my next poll question. Leads up to my next poll question here. And this is interesting because I talked to, especially in the past couple of years, when I started to feel like Galileo system was becoming a reality, I talked to a lot of people who still say, hey, they don't believe it's going to happen. They have some doubts about it. But I'd like to understand, what you think about it. So the poll question is, what do you think about Europe's Galileo system? And the answers are, I don't know. I don't believe it's going to be completed. Certainly a valid question, and I still get it today, or a valid opinion. Number 2, it's an important consideration in my future GNSS receiver purchases. Number 3, I'm interested but waiting to see how it progresses. Number 4, I don't see the value of Galileo. And some of you may say that, if you're using GPS and GLONASS today and it's performing well for you, then what's the value of adding Galileo? And then 5, you don't have an opinion yet. So go ahead and select one of those, and then we'll I'll wait here for a minute and push the results out to you. Okay, so Joe, if you don't mind, can you go ahead and push the results out? So 2% of you believe it's not going to be completed. And it's interesting, and maybe it's because of my influence here, I'm not sure, but in the past that hasn't been the case. A lot of folks didn't believe Galileo was going to come around. On the second question, 36% of you believed it's an important consideration. 56% of you believe you're going to see how it progresses. Very few believe there's no value, and 4 don't have an opinion yet. But that sort of makes a lot of sense to me because it's sort of wait and see at this point. But I tell you, there's a lot of momentum there, and if they really, I think the key milestone for me is next summer, or maybe it ends up being next fall if they push it out a little bit more. But the key is when they start launching them in production mode, because they're really going to be able to crank them out and send them up into orbit in a hurry based on their current plan. And if they end up doing that, it's really going to change the landscape, I think, of GPS receivers of the future. It's really going to be a different ball game. So just a quick update on GLONASS. Declared fully operational back in December last year. 24 operational satellites, the most since '97. It's been a valuable augmentation to GPS. I mean, and it's still not used as a standalone system, at least here. I think in most markets. I mean, I think in Russia it probably is to some extent, but in most markets it's used in combination with GPS. It's been invaluable for high precision RTK users because it really increases productivity. I mean, even today with today's GPS constellation, you still get times during the day when there aren't enough satellites to get a reliable horizontal and vertical position using RTK, because RTK it's a satellite-hungry technology. You need at least 6 satellites, solid satellites being tracked all throughout the day to be able to use it consistently. And there's just areas, or sometimes during the day when you're near trees or in rough terrain, the constellation just isn't, the number of satellites just aren't there to be able to use it. And so Galileo sort of puts you over that hump. And anybody and everybody I've talked to who use GLONASS along with GPS say, hey, the productivity is fantastic because you can work throughout the whole day without having to worry about having enough satellites to work with. And I'm a user of it too, and so I can back that statement up. It adds about 5 to 8 satellites when you're using GLONASS, so that's really the big difference. It's a common feature in high-end surveying receivers. It wasn't 10 years ago, but certainly it is now. And you're also seeing it being added into mapping and consumer receivers. I think the new iPhone 5, if I'm not mistaken, it's got GPS and GLONASS capability. And an interesting fact is that based on some studies, GLONASS doesn't necessarily improve accuracy other than improving PDOP, but it really does improve productivity, and that's really what it's all about. And sort of an important point in here, and I've made this point before, is that there's a fundamentally different radio design between GPS and Galileo. And it's just, it's GPS and GLONASS. GLONASS is based on FDMA technology, and GPS and Galileo and Compass are based on CDMA technology. And the best way to explain it, I think, is just like your different phone systems. AT&T uses GSM, and Sprint uses CDMA, and those two aren't compatible, and so you've got to have 2 different radio designs inside one box to be able to use both of those different systems. It's just a quick slide here showing you how GLONASS has sort of transitioned since its low point back in the early 2000s. At the low point, I think we were down to 7 operational satellites. You can see over time how it's improved up to the operational status that it's at today. And this next slide shows us the signal plans for GLONASS. And they actually have plans to, develop an L5 signal you see down at the lower right-hand corner in red, and then B, also to transition to CDMA, because of course they don't want to be left out, because all the other GNSS around the world support or are designed around CDMA technology, whereas GLONASS is the only one supporting FDMA. And so in order to be compatible and easier, to make it easier for system engineers to design GLONASS into their receiver designs, I think the Russians figured out they had to transition to CDMA. Now the key is how fast they can do that, and it's, because the space business is a long-term business, and it's not easy just to you can't just change from FDMA to CDMA by sending a message to a satellite. You actually have to launch new satellites. You have to have new designs, launch new satellites, and that's an expensive and long-term proposition. So the issue ends up being, are the Russians going to be able to address these issues fast enough before they are sort of aced out by Galileo and even Compass at some point? So this next slide shows, sorry, it's a little bit slow displaying here. Among the new, and I've touched on this a bit, but among the new GLONASS satellites is the GLONASS K model, which includes a new radio design, CDMA. And again, it will really greatly improve its compatible with GPS and Galileo and the Compass system. But again, the timeline to transition to CDMA it's a long-term prospect, and it's likely that Galileo will have a full 30 satellite constellation in orbit before GLONASS even transitions to CDMA. So the question is, will Galileo replace GLONASS as sort of the second GNSS constellation? So that leads to my third poll here, about what do you think about Russia's GLONASS system? And then there's still a lot of attitudes about this when I talk to people about GLONASS. One of the answers is I don't think it's reliable, so I don't use it. That's one valid answer. The second answer might be I use it and it's a valuable feature to my receiver, and that's certainly an opinion I would have. I've used GLONASS and it's been a valuable addition to my receiver productivity. And number three is I don't see the value of GLONASS. Number four, I'm considering adding GLONASS feature to my receivers. And then number five is you don't quite have an opinion yet. So go ahead and select one of those and select to submit your answer. And I'll push the results out there. So Joe, if you don't mind, could you go ahead and push display the results to the audience? That's about right. That's about what I expected, I think. 3% you say it's not reliable, so you don't use it. 52% say it's a valuable addition. 3% say you don't see the value, and 18% say you're considering, and then 25% say you don't have an opinion yet, which is reasonable. But certainly, GLONASS has made a huge comeback. A few years ago, I wrote an article called "The Comeback Kid," and I think that's really relevant, or really accurate. I think is 10 years ago, GLONASS was not even being considered by many people at all, and now it's standard for high productivity, high precision type of GNSS receivers. So a quick overview of China's Compass BeiDou system. I don't have a lot of info on it yet, but I can tell you this. Right now, their immediate plan is for a regional system. In fact, it is a regional system in China, so it covers this area that you can see where the red rectangle is drawn around. So that was their plan, as far as I know, is to launch a regional system just for their own use locally. And then, and that was declared operational back in 2011, the initial operational capability, with 15 satellites in varying orbits. And then they're going to launch another one scheduled very soon, here in the next few weeks, I think. Their long-term target is to have a global service similar to GPS, GLONASS, and Galileo. And the last the last presentation that I saw said that the plan was to be operational with that global system in about 2020, so eight years out from now. And again, the key thing here is it uses the same radio design as GPS and Galileo. It uses a CDMA radio design. And it might gain wide support due to the size of the Chinese market. I mean, if you think about it, the Chinese government may say, hey, look, if you want to sell GNSS receivers in China, you've got to support Compass BeiDou system. And so that fact alone, manufacturers and GPS manufacturers, GNSS manufacturers and GNSS chipset designers may just add that in there. A, because it's fairly easy because it's the same CDMA design as Galileo and GPS, but B, just because they want to make sure they can sell product into the significantly sized Chinese market. So the other issue I want to talk about beyond these global systems is satellite-based augmentation systems. And remember, SBAS are a regional system, and there's essentially 4 systems in use right now, with the 5th being developed. The biggest one being WAS here in North America that covers Mexico, Canada, and the U.S. It's got actually the actual Geo Satellites aren't very accurate here. I haven't updated this map in a while, but there's actually 3 Geo Satellites in broadcasting WAS corrections throughout North America, and there's 3 over in Europe. You see that green one in the middle, that green polygon, and then further to the right is a GAN system in India, and then lastly on the far right is the IMSAS developed by the Japanese. There's got 2 Geo Satellites, and I've got some specific information on the Geos that I'll display right here, starting out with WAS system. So WAS has got 3 Geo Satellites, and the Geos are these geosynchronous satellites, so they don't move. They don't have orbits similar to the GPS system. They're not moving across the sky with respect to ground users. They're always in the same place in the sky, depending upon where you are in the coverage area. And there's 3 satellites that are broadcasting WAS corrections. You can see those on the slide here: PRN 138, 135, and 133 at different longitudes. They're all over the equator. So the further north you go, for example, up in Alaska or northern Canada, the lower on the horizon these satellites, the satellite view are. So, and what's interesting is lately, I guess, WAS has been around for almost 10 years now, and it's widely used. But lately, what's been interesting is that some manufacturers have begun incorporating GLONASS into their SBAS solution, including WAS, even though the SBAS reference stations don't support GLONASS, which is interesting. So they've used some pretty slick techniques, and I can't explain to you exactly how they're doing it, but I've used some of that technology, and it's pretty neat because traditionally it's been if you wanted to use WAS, you could only use GPS-only satellites, because that's what the WAS reference stations are. They're only GPS. But some manufacturers have come up with some neat techniques to be able to generate corrections for GLONASS observables too from the WAS, from the WAS-enabled receivers, and so they're able to take advantage of many more satellites that GLONASS adds, and also take advantage of the accuracy that WAS provides. And so, especially if you're talking about using, mapping grade receivers underneath tree canopy around buildings, that's where you see a great benefit. Because some receivers out there, if you enable WAS and they're GLONASS capable, they automatically disable GLONASS. And so, of course, you lose out on 5 to 8 to 9 more satellites in view, which can make a difference, a big difference in when you're mapping in a sort of troublesome environment. So WAS is, and further down the list there, WAS is transitioning towards supporting dual frequency L1, L5. In fact, they're transitioning away from L2. And they expect to begin supporting L1, L5 operations in this 2018 timeframe, and that's based on a slide I saw from the FAA down at the ION conference a few weeks ago. And there's no plans to expand coverage, the coverage area. It already covers, again, most of Canada, the U.S., and then Mexico. And actually, you can even use it up in Central America and in the northern tip of South America for ground users, for non-aviation users. There's no plans to expand that coverage into South America. Now, the Brazilians or other South American countries may have their own plans for that, but I haven't heard any here recently. So the second SBAS is the EGNOS system, which covers Europe and Western Europe and North Africa, and it's got 3 geos, and I've got the PRNs and the positions of those satellites listed here. And it's interesting, what the Europeans have done also is they have, in addition to delivering corrections from the Geo satellites, they also send out corrections over the internet, which is interesting because, you know, you have to be a line of sight to the geos to be able to receive the EGNOS corrections. But if you're in a tunnel or some other area that's really difficult to receive or to be able to view that geo satellite, you can also receive those corrections via the internet. So they have the system called EDOS, which enables you to do that, and it's actually a very interesting system. EGNOS is looking to expand into Eastern Europe and into Central and Southern Africa also. I saw some slides that were presenting that sort of concept again a few weeks ago down at the ION conference, and it could really, I think, be a boon, especially to Africa, which has such a huge area. And if you can get, you know, meter level positioning for mapping down that area with a really low cost GNSS receiver, boy, that would really help out in the GIS database development in that area. The next system is MSAS in Japan. There's 2 geo satellites. It's been operational actually for quite a while. It's been operational since 2007, but it just covers that sort of regional area there. It covers maybe a little bit of northern Australia, I think. There's no reference stations down there, so you're really extrapolating, but you may be able to get some benefit from it, but certainly not for the bulk of Australia. But primarily, it covers the island of Japan. The Gaggan system in India is another SBAS. There's 2 geo satellites, there's one broadcasting and one that was just launched very recently. And this has been in development for quite a while. There's lots of, it's a really dynamic area for the ionosphere, so there's lots of reference stations there that have been implemented. It's not operational for aviation yet, but I've seen some data from ground users there that look pretty good. And so I think it's just a matter of time, especially once this other geo comes online. I think it's really going to help the development of GIS databases there also, you know, because meter level type of receivers will really put low cost, high precision type of capability in the hands of a lot of folks there. And then lastly, we have the SDCM system in Russia, which is Russia's version of their SBAS, and there's one geo satellite was launched already, and it's located at 16 degrees west. They've got another one scheduled for launch in November 2nd, just about a few weeks from now. It's in the very early stages of development, but you know, I think they'll come on board just like the other SBASs have. And I think it's you know, even though they're targeted primarily at aviation users, this SBAS has been such a fantastic technology for surveying and mapping users. I mean, if you look back since WAS became operational back in 2003, look at the proliferation of low-cost, high precision, and by high precision I mean that, you know, meter level, sub-meter level type of receivers have become really inexpensive, and been able to put that kind of capability in the hands of a lot more people. So then there's, you know, the ones I've talked about previously have been these public SBAS systems that have been free of charge, so free to users. So that's WAS, EGNOS, MSAS, Gaggan, SDCM. They're all public free signal that you can use. They were all developed for the aviation industry, but us as ground users can use them free of charge. Now there's also commercial SBAS out there, and you've heard of some of these before. You know, there's OmniStar, which has been around for a long time, initially offering a sub-meter service, but then they from pressure from WAS, they transitioned down to offering a decimeter type of service, which they're successful at today. There's the Starfire system from John Deere, which services the ag market primarily. And then there's Trimble's new RTX service that gets you down into the centimeter level. I don't have any experience with it yet, and I don't know how it's performing or how reliably it's performing, but certainly I think they'll get there, just a matter of time. But that'll get you down to, you know, a centimeter, 1 to 2 to 3 centimeter type of service. And then there's also a new entrant, which is interesting because OmniStar was sort of the only game in town, at least here in North America, for a long time. There's a company called TerraStar that introduced their service at the Intergeo conference just a couple of weeks ago in Europe. But they're launching their service here in North America, and I think in other regions of the world for an OmniStar-like service, it's very similar service. And so I think from a user community perspective, I think it's great for us because the more competition, the better. That'll make both of the companies better and probably drive prices down a bit. In fact, I was just inquiring about a week ago or so about service down in South America, and I was surprised at how much the prices had come down in South America. It used to be quite expensive for service down there, but I think OmniStar's G2 service, which is GPS GLONASS for 10 to 15 centimeter accuracy down in South America, is now $1,200 a year or something like that, right around that area. And it used to be a lot more expensive than that. So it's really, it's been great, I think, for the end user community to have more competition. I'm sort of glad to see this happening. So the other, I've got a lot of images on this next slide, and so it's probably going to take a second here to display it. So just some other couple of newsy issues here to talk about. And I haven't really written about this much lately, and I've meant to, but I've been jammed up with some other stuff. But for users here in the U.S., the FCC has this new narrowbanding ruling that's going into effect. Actually, I got the date wrong there. It should be January 1st, 2013. So just a couple of months out, FCC they already have made this ruling. In fact, it's been out for a couple of years now, I think, or a year and a half or so. But it actually begins January 1st, 2013, where the rules for UHF radios are changing. It used to be that your radios used a 25 kilohertz spacing, and the FCC, in the name of increasing capability, increasing throughput using the same amount of spectrum, wants to cut that in half down to 12.5 kilohertz spacing. And so your radios have to comply with that you're using for RTK. And there's been a lot of, I think, discussion and ambiguity about this. But the bottom line is you need to check with your local dealer or your radio supplier, radio manufacturer, to understand what you need to do to transition your radios from this 25 kilohertz spacing down to 12.5 kilohertz spacing. Or I think the other option is that you can if you raise your baud rate on your radios up to 19.2, then you can comply in that manner. But you start to run into some issues with radio baseline distance. Your distance becomes more limited. Some radios can't, or some receivers aren't suited well to handle that baud rate, and so it could be more complicated than you think, and it could be fairly expensive if you have to upgrade all your radios or have to replace all your radios. There has been, I've seen some cases where they've been able to upgrade radio boards and so on, but there's a cost associated with that. But anyway, especially if you're working in metro areas, highly populated areas, this is going to be a somewhat serious issue. Not as much in the rural areas, but regardless, whether you're in the rural areas or the urban areas, this is a rule that's being implemented by the FCC, and it kicks in January 1st, 2013. And so I'm going to try to get an article out on this here in the next month or so with some details on that. But certainly you shouldn't wait for that. I'd call your dealer or the radio manufacturer of the UHF radio that you use and check with them. Now, it doesn't affect, if you're using, CDMA modems or GSM modems, that sort of thing to tie to an RTK network. That doesn't affect you at all. It's only UHF radios for which you have a license for in the U.S. already. Just some update on LightSquared. There's been a little bit more noise lately. LightSquared has proposed that they do a spectrum swap. They've identified a piece of spectrum up in the 1680 range, and they're proposing that they abandon the piece of spectrum closest to GPS, the 10H signal spectrum. I'm not sure it's too real yet. I mean, LightSquared proposed a spectrum, or they talked about a spectrum swap last year about this time with the DoD, and of course that didn't go anywhere. And this spectrum up in the 1680 range that they're looking at is used by NOAA now, I think, for some weather-related type of uses, and they want to share that spectrum with NOAA. And I haven't seen any statements from NOAA yet, but I sort of have a hard time seeing it's going to fly. But I wouldn't be totally surprised if it did, but I don't give it a high chance at all. So they're still around. They're scrambling to try to put their system together still, but it's looking dimmer and dimmer. But certainly, no matter whether they move forward or not, the whole issue of using spectrum more efficiently is a serious consideration, and one that the FCC is looking at very closely in terms of trying to establish GNSS receiver standards and or protection, a guard band of some sort around the GNSS spectrum to make sure it's protected. Probably end up being a combination of both of those, some receiver standards as well as some guard band to protect the area around GPS to make sure that that's secured for the future. I'll probably write a little bit more on that, but unless something really serious happens, I doubt you'll hear much about it in the future. The third subject there is UAVs. When I was over in Europe just a couple of weeks ago at this EricGakstatter conference, you can't imagine the number of UAVs I saw there for mapping, that were designed for mapping or adapted to mapping. I mean, there's probably 15 or 20 of them, different types. There's helicopter type. There's fixed wing aircraft. There's all kinds of different UAVs, and here in the U.S. we don't have the FAA doesn't allow any commercial operators to operate UAVs, but in the rest of the world they do. So just a matter of time, I think, before you see it here in the U.S., and I think that's really going to be interesting in how it affects the GIS and mapping industry in general. Because boy, if you can deploy a low-cost UAV and be able to map an ag field or a wetland area, almost immediately for really low cost, that could be very interesting, I think. And I think it will be. I think it's UAV technology is a major disruptive technology for mapping in the future. I mean, just think about it. If you don't have to wait to deploy a manned aircraft, if you can take a model out there and within an hour or hour and a half, you can launch it, collect a bunch of data, come back to the office, and a day later have somewhat ortho-rectified imagery that you can work with. Boy, that'd be a powerful tool. And then there was a bunch of new GNSS products introduced at EricGakstatter in Europe. The one on the left there, I don't know if you can really pick it out, but that's a product from Leica that's got sort of a helical antenna that looks like a Tootsie Roll sticking out the top, but that's actually a dual frequency antenna, and they got a dual frequency receiver built into that tablet computer to get you down to 5 to 10 centimeter accuracy. The second image over there is an image of a product that was interesting how I came about this. They actually didn't display at the EricGakstatter conference. I actually ran to this guy at a pub. We were having a get together with some sat nav users there in Europe, and he pulled this thing out, and it was really cool. He took a smartphone and he attached a laser rangefinder to it, as well as a GPS antenna to it, and he was doing as well as a telescoping lens. And he was doing some really cool augmented reality kind of stuff with it. I mean, it was pretty amazing for as low cost as what he was talking about and high productivity. It was really, really kind of a neat product, I thought. Up on the third image from the left on the top there is Trimble's new R10, which is a lot of folks were talking about this at the show. It's really no new serious capabilities in terms of GNSS processing, but boy, the size on that was so small, it's unbelievable. I mean, it was just really, really tiny receiver, probably the smallest one I've seen as far as the finished goods receiver. Now, right below that is a new product, a dual frequency OmniStar worldwide GNSS type receiver. I mean, what you're starting to see here trend-wise is stuff is becoming a lot smaller, as you would expect, becoming cheaper in some cases. And I think you're just going to see this trend continuing especially when this L5 signal comes on board, is you're going to see receivers getting smaller and smaller and cheaper and maintaining the same accuracy, the centimeter level accuracy. And on the far right there was a helicopter UAV demo outside at the conference in Germany, and I snapped a shot of this. It was 6 propellers on it, and this thing would, it's battery powered, and you had a remote control, and you could fly it around and hover over stuff and take pictures, high resolution digital photos, that sort of thing. just a lot of neat new technology over there that I saw. So this leads me up to the last poll question as we sort of finish up here. And I'd just like to know, and it's just sort of an open-ended question, and I wish these polls were a little bit different and that you could just type in your own answer. And we can do that, but it's got to be sort of a different way, and I'll explain that here. So the question is, what issue concerns you most today regarding GPS receiver technology? And the first answer is the technology is moving too fast for me to keep up. That's a valid answer. I don't want to buy equipment that may become obsolete too quickly. Certainly a valid question given the changes that we're seeing over the next few years. Third one is your concern might be radio interference from other technologies, like LightSquared or other kind of interference issues that might be out there. Fourth concern may be that this technology is still too expensive, which is certainly a valid concern. I think it's going to change, but certainly, if receivers are in this $10,000 to $15,000 range, it's still quite an expensive capital expenditure. And then the fifth answer, and we can have a creative way of doing this. If you don't like any of the answers here, you can go into this Q&A section of the webinar, and just type in your comment there. Just say, hey, I'm not concerned about those, but hey, here's what I am concerned about, because I'd like to hear about it. I just thought of these first four off the top of my head. It doesn't mean that they're accurate, that they represent what you're thinking. But if you think of something different, well, I'd really like to hear about it. And again, just go to the Q&A tab on your window there and just type it in. Just say, hey, I'm concerned about X, Y, Z, and this is my major concern. So I'd love to hear about that. And I'll pause here so you can go ahead and do that. And then this last slide here is really interesting. This is something I saw at the EricGeo conference in Germany, and this is the oldest mapping device that I've ever seen, I think, and it's from the 18th century. Of course, it's not battery powered, but it's how this particular person and I don't know how many users there were of this particular device out there, but I'll display the image right now so you can see it. So they had this on display there. So if you can imagine, they'd pull this cart around, and it would draw. You see that pencil right there in the middle of the cart, and there's a piece of paper there. It would draw the path that this cart took, based on turns and twists and that sort of thing. And I'll display another view of it right now. So as you pull this cart around, I'm sure of course it was horse-drawn at the time or man-drawn, and this pencil would draw a map as you pull this cart around the field or down a road, I guess, whatever road they had at that time. But just fascinating. So what happened is I talked to the engineer who was sort of explaining this system on site there. He said he found antique drawing, and he bought it for about 2,000 euros, drawing of the system. And then he went to Volkswagen and had them actually build it based on these engineering drawings that they had of this particular cart from a couple 300 years ago. So anyway, fascinating. So I'm about out of time here. It was great. Glad you could tune in today. Please, at any time, if you have any questions or comments or anything, send me an email at EricGakstatter@gpsworld.com, and I'd love to hear from you how you're using technology, any complaints you have, any praise you have, that sort of thing. But thanks a lot, and I appreciate you coming out today. And I'll pass it off to you, Joe.
Eric, do you want to push the latest results on the last poll?
Oh, there you go. Yep. That's a good idea. Let me do that.
They're there, posted now.
There you go. Yep. Makes a lot of sense to me. I'll address that. It's an interesting question to me. I'll address that in my next newsletter. So, yeah, thanks for the reminder, Joe. Appreciate that. Back to you.
Okay, and we've recorded the webinar, so we will be posting this online at gpsworld.com in the next few days. We'll also send out, for everyone who's registered, even if they missed today's session, we'll send out an automatic email reminder when that becomes live. This concludes today's webinar. Thank you for attending.